Okay, our next presentation is identifying and protecting architecturally significant code. And our speaker would be Mehdi Mirakhorli from DePaul University. Mehdi is a doctoral candidate at DePaul University with a research background in software architecture design, requirements engineering, and agile processes. Previously, he worked as a software architect on a large data-intensive software systems in banking, meteorological, and healthcare domains. He has served on the program committees for several workshops and conferences and as a guest editor for a special edition of IEEE software on the Twin Peaks of requirements and architecture. Please welcome Mehdi.
Hello everyone, this is Mehdi Mirakhorli from DePaul University. Thanks for attending this session, and it's my pleasure to have the opportunity to share the results of some of my work with you. Today I'm going to talk about software archaeology, identifying and protecting architecturally significant code. Basically, I'm interested in bringing architectural thinking into programmers' daily activity, and this talk is about that. Today I'm going to talk also about Archie, which is a tool suite initially developed by the support of National Science Foundation. Later, it got supported by Department of Homeland Security and is at the stage of technology transfer there. Talking about architecture, let's start with architectural failures. The media is full of stories of software systems which failed due to architectural problem. For example, one Illinois hospital, jointly managed by the Department of Veteran Affairs and Department of Defense, failed to achieve interoperability between their department subsystem, costing the hospital at least $700,000. And that's despite the fact that Department of Defense and VA have already spent $100 million to achieve this quality. Another example, I'm sure everyone remembers it, that's Obamacare. A few days after the launch of federal government's healthcare.gov website, 8 million Americans were looking for information about new health insurance plan, were locked out of the systems. The designer tried to tweak the system, increase its availability, but it didn't work. The issue was later recognized as an architectural problem. But was it just availability? Later on, it was revealed that actually Obamacare website had several security problems. Someone with following simple steps could retrieve user's username, password reset code, security questions, and email address from the system. Architectures fails for several reasons, but most of the time, if architects make design decisions, they make right design decisions. Sometimes architecture fails because of things that happens after design. Let's get more technical. I want to show you examples of architecture and examples of things that can happen in an architecture. Here is an example of Apache Hadoop architecture. Hadoop is a framework for parallel computing. It implements MapReduce paradigm. So what you see as an architecture is a collection of components and a collection of design decisions. Whatever you see in an architecture have a reason. If you see an element, there has a reason, and that reason is the requirements or business goals behind the elements. Here, for example, in Hadoop, the stakeholders wanted to have a highly fault-tolerant system. Then designers came up with a set of design decisions using master-slave architectural style where slave processes are replicated. Then using checkpoint architectural tactics to synchronize the replicated processes, using heartbeat to detect if one of the replicated slaves failed or not, and recovering the failure process. Then using proxy in order to shield the failure from the client. Another example of requirement, high throughput access to the application data. The designers, again, used master-slave architecture style with replicated slave processes to contribute to the performance. Then they used a couple of scheduling strategies like FIFO, fair scheduler, capacity scheduler to satisfy these requirements. They used thread pooling and several forms of task performance monitoring, rescheduling, and balancing. Once we look at the small to medium scale software, a non-trivial architecture is likely to have, if not thousands, hundreds of such detailed design decisions. Each of these design decisions are driven by requirements. But unfortunately, many of them are lost during the design process, during the realization of software and evolution of the software. That's what we call architectural decay. You have a well-modularized architecture with a lot of optimum design decisions. After 5 years, what you get is a big ball of mud. Has anyone used Hadoop? Okay. There was a time that I said the same thing, and someone told me that, hey, I have used Hadoop, and it works very well, and you call its architecture a piece of crap. I think it works. Then my answer is that this is the architecture. It's a fact. It's a big ball of mud. It has a lot of architectural tactics there, but they maintain this complex architecture in different ways, in social ways. There are a military of programmers there that share the design knowledge on the firm. That's not my focus, but let's look at some of the issues that has happened in Hadoop. I looked at some of the patches that developers had, contributors of Hadoops had in their forums to fix things. And I looked at cases that those patches actually violated some of the architectural rules. Here's an example. In Hadoop, we have two class files, name node and data node. Name node plays the role of master in the architecture. Data node plays the role of the slave. The role of data node is data manipulation. The role of name node is just a lookup table. So we want to make sure that if the data node crashes, the master knows it. The developers have used Heartbeat to monitor the failure of the data nodes, the slaves. So periodically, data node sends messages to name node. And sometimes there are other messages. Once it sends every 10 seconds, for example, Heartbeat message. Sometimes it sends block reports. Sometimes the blocks to be deleted, and etc. So what happens one time a programmer comes, he's not aware of architectural decisions behind all these complexities. He says that, oh, I can do piggybacking. Let's merge all these messages together. Why we should make so many method calls? We make one method call, and it does whatever we want. But what happens that the block reports are usually delayed because they deal with the data with the DX. Sometimes they can send the block reports in 10 seconds, sometimes in 20 seconds. Then all the time, most of the time, system thinks that the data node has failed because it hasn't received the Heartbeat message, and it launches the recovery process. Another programmer comes and fixes this issue. Okay, every 10 seconds we data node sends a message. Either it's block report or it's an empty message, Heartbeat message. That fixed the issue. Over several releases, again, another problem happened for the same part of the system, that someone comes and in order to make system highly available, change that 10 seconds to 2 seconds. The system goes to the trashing mode. Performance drops. So little changes at the programming level compromise performance of the system and introduce trade-off between performance and availability. Why such kind of architectural problem happens? It's because the way we develop software. In ideal world, once a change request comes, the first thing that we do, we look at the impact of change on architecture. If it doesn't impact the architecture, we go ahead and implement it. But if it impacts the architecture, we ban the change, we negotiate the change, and sometimes we go and adopt the architecture. So there is an alignment between intended architecture, what we wanted, and is the architecture in the code. But in reality, the only thing that we care about is the code. There is no architecture document. architecture is tacit in head of people. Many times, those people who actually work on the system are those who have not been engaged in early design phase of a system. They are unaware of design decisions. Sometimes they have made design choices, but they forgot it. So intentionally or accidentally, they make changes to the system that those changes violate key architectural decisions. Then there is a drift between intended architecture and implemented architecture. Eroded architecture, in simplest case, becomes complex, difficult to understand, and difficult to maintain. But in severe case, it makes a software company, a software product disappear from the market. Is it a made-up problem? Netscape was an example of that. Netscape during the browser war was in competition with Microsoft, right? What happens, they wanted to beat Microsoft, so they wanted to add new features. But their architecture was eroded. They couldn't add the features. Then they went, sued Microsoft, and they said in the court that Microsoft was devil. They are the reason that we failed. But the problem wasn't Microsoft, partially. And the solution wasn't the court. The problem was architecture, and the solution was in the architecture. How can we deal with the problem of architectural decay? Our vision was that if we could have a smart IDE, that whenever a developer comes and modify a piece of code, and that piece of code tends to be critical code, architecturally significant, means that that piece of code implements something about security of the system, something about performance of the system, and architectural decisions behind. So we want the smart IDE to recognize it, send a warning message in the warning list telling the programmer, hey, be careful. This part that you change actually implements audit trail, and it impacts security of your system. This part of the code that you change implements thread pooling or implements blackboard architectural styles and can compromise your performance. So we wanted a tool that could understand architectural decisions in the code and also visualize that design knowledge for the programmer, so the programmer understands why the program looks like the way it looks like, how different elements in the code interact with each other in order to implement an architectural choice. So that's the focus of my talk from now. Archie, a tool suite that we developed, which is able to detect several kinds of architectural tactics in the code. And primarily, we customized it for the Homeland Security, which detects over 30, 35 security choices in the code. Archie has several features. One of them, which I'm going to talk about these features. The first feature is about detecting and monitoring code snippets that implement key architectural decisions in the code. So what we have done, we have developed a decision detector. What is that decision detector? It's a rigorously validated automated technique based on combination of data mining methods. I'm not going to talk about those data mining methods, but what I can tell you, Archie, which by the way is the name of the professor that I was working with, it's the name of her dog. Then I realized it's a good match for my tool because it looks like to be something about architecture. So we trained Archie. How did we train Archie? We collected about a few hundred samples code of architectural decisions in open source community. Then Archie looked at those codes, and if you give him any project, or give her any project, it can figure out if that project has any kind of architectural decisions in it or not. It works based on terminology. So by looking at those 100 sample codes, it trains all the keywords, terminologies, APIs that programmers use to implement an architectural decision. Here is example code for audit trail, which if you look, there are some keywords, audit, log, and things like that. For thread pooling, if anyone implements thread pooling in any language, you have to use the name thread, suspend, start, sometimes worker. So we looked at several projects, a big repository of sample code snippets for different architectural tactics. After training Archie, it's capable of identifying these tactical codes in any project. Here I show a snapshot of Archie. Currently, Archie is implemented in 3 different forms. One of them is a plugin for Eclipse. Basically, you can open any project in your workspace, scan it, and it detects a list of architectural choices in the code. It detects, for example, in Hadoop, yarn server project. It detected that there is secure session management, role-based access control, heartbeat, scheduler, pooling, ping echo, load balancing, Kerberos authentication, policy-based authentication, and audit trail. Here I show a little code snippets of audit trail. Also, it highlights why it thinks that audit trail is there. Basically, highlights the comments, API's name, method names, and so on. Another example for heartbeat, you see that send, ping, receive, ping, heartbeat are the terminologies which are highlighted. Another feature of Archie is that it's proactively keep developers informed of underlying architectural decisions during maintenance phase. Most of the time, once we are programming, IDEs do a perfect job about syntactical errors, right? If you don't write something else, they tell you. Semantical error, they're okay, they do something. But about rational, architectural mistake, design errors, they do nothing. Our vision is that we bring this into programming environments, that you have a tool that tells you, hey, the technical debt of your program is high because I see it there. You have vulnerabilities in your design choices because I see it there. You have violated some of your design decisions because I see it there. So we wanted to have that as smart ID. Then Archie also have features for communicating that design knowledge with the programmers, also visualizing it. Example of visualization, basically it shows modules of a software system, office software, and it's colorized it with different colors. For example, yellow shows the modules that have implemented thread pooling. So you see the structure of software, and you see which module implements which architectural decisions. Then also Archie performs change impact analysis at architectural level and also at code level and design level. Basically, we have an asynchronous event-based monitoring and notification infrastructure. So if the programmer comes, modify a piece of code which is architecturally relevant, Archie recognizes it and notify the developer. Here is an example that heartbeat in Hadoop HDFS project. And here the circle shows the heartbeat period, which is 10 multiplied by 1,000 millisecond. A programmer comes and changes 1,000 millisecond to 10. Then Archie realizes that, oh, someone changed something related to heartbeat. So it highlights, shows a warning sign on the file which was implementing the heartbeat architectural tactics, and the developer can see that they've made modification to parts which are sensitive to architecture. Then also at the same time, Archie sends a warning, shows a warning message in the warning list of the developers, which are design warning, basically. The developer sees them, and if they basically accept it, indicating that, hey, I looked at my change, I realized that I haven't violated anything, that's okay, don't show me this warning anymore. Archie basically ignores that. But if they don't perform a code review, that message would stay there. Another example is that Archie also let the developers visualize their own design decisions so they can model whatever they think about the architecture. Then Archie lets them semi-automatically map source files into their models. They just need to select any class diagram in the model and click the elements that Archie has automatically identified as that type of architectural tactic or architectural decisions. Here for heartbeat, for example, a developer in Hadoop has mapped these source file into heartbeat emitter and heartbeat receiver, and the highlighted one indicates that someone has modified data node management, which plays the role of heartbeat emitter in Hadoop and heartbeat tactic. What we did, we ran a simulated experiments. Basically, we got Hadoop's change logs over past 4 releases and simulated how many notification message would we send to the developers, how many of them are relevant to the architecture. Because our approach is a data mining approach. Behind, we have all those AI techniques, right? It has a precision rate. Here it shows that for audit, we were able to correctly notify the users, the developers, for the messages, changes which were related to audit with the precision of 99%, for heartbeat with the precision of 96%. Scheduling was slightly lower with the precision of 0.73%. The other feature that Archie has, it enables the developers to automatically trace external architectural specification documents to the source code or design model. Many sensitive organizations that develop safety critical products, develop healthcare products, develop defense products, their software products needs to satisfy some regulatory codes, regulations, standards. So what happens, all those standards and specifications are outside their development ID. Someone later needs to go and match all the source codes with those regulations to make sure that they satisfy those regulations. For example, FDA, Federal Drug Administration, they have the same issue that if they develop a product like pacemaker, they need to make sure every line of code matches to their requirements. Every line of code satisfies their regulatory standards. So Archie basically have a search engine there. If you're opening one Java file in front of you, you click a button, it goes to your local drive, retrieves all the piece of standards, a specification, regulatory code which are relevant to the code that you're working. Currently, Archie, as I said, has several different versions. 3 versions, one a standalone version that someone can use by itself, not in any IDE, a plugin for Eclipse. And also, it has a version which is integrated with Software Assurance, DHS project, Software Assurance Marketplace. SWAMP basically is one of DHS projects that they are collecting several security tools that developers or researchers can go in the pool of these tools and use different tools to run experiments, to check things on the projects, and so on. You can find it online if you Google SWAMP Software Assurance Marketplace. A version of Archie is integrated into SWAMP, and later we are going to use it to perform vulnerability analysis at the level of software architecture. Here is a snapshot of Archie, which basically on SWAMP shows that you could go select several tools. Here I've selected only Archie. There are several other vulnerability analysis tools. You can run it on any project that you have there or any project which is available there, and you could have the results. SWAMP has a parallel computing infrastructure, several servers, so it makes it easy for people to run massive experiments and also do overlap analysis. For example, one of the next thing that we are going to do is get the overlap between security decisions that people have made in several open source projects and well-known vulnerabilities in those projects. At the end, my message is that software architecture research is very important, and thank you. I would be happy to answer any question.
So one thing I'm wondering is, most of the numbers you showed about warnings is that with the existing warnings, some development teams tend to ignore them already. And
that's one of the mistakes for ignoring the warnings. I think that's a mistake by itself. But we need a way of highlighting them. We cannot make it error. We want to make them as error, but errors are blocking. Sometimes they need to ignore them and think about them later. But we want to give them that flexibility. If they want to ignore it, let them ignore it.
Have you also had some experience where you worked with a project team and got some feedback from that?
So there are a couple of companies that work with DHS. They are using it. Their main purpose is that at this time, it's not really mature. They are basically giving us further feedback, which features can be integrated with it. But at the stage that it becomes being used in a company thoroughly, no. It might happen in a year, But at this stage, we are just basically sending to random companies that work with DHS, and they give us further feedback. And their feedback is more in form of features that we include in Archie. But anyone who is interested, I would be happy basically to share it.
Any other questions?
Yeah, I really like the tool, but I have a concern about the effort, the cost of producing all this mapping between the design decisions and the things in the code. But I think if you have a critical project, you have to do it, but then it comes the situation in which perhaps you have a new project that shares some similarity with the previous one, and then I'm wondering if you have to remap all the decisions that you had to the code, the previous one. I mean, you get all these benefits when things are partially mapped to the code, but what happens when you are starting the project? So you have to remap things again, or what about the effort of creating, in your experience, these kind of rules or traceability links between the architectural decisions and the code?
So at this stage, what happens that if you carry this project that you have open in your workspace and become, like you're using Maven on several projects, if you bring this project, import it to another bigger project, all those links will be carried with the current project. But probably we could make it also as the lower level of granularity, that the links for the modules can be shared with the module. If someone reuses that module, can be shared. But one aspect of Archie also is that it generates these things automatically. You don't need necessarily map them to those elements I showed. If you want, you can definitely do that in semi-automatic way. But also it does this kind of identification automatically. So for a new project, you could always say that I trust Archie. I'm okay with the precision of 90%, or some case 80, 70%. It might give me 30% of false positive. I do nothing, no manual work, and I trust it. So once you go to a new project with the percentage of error rate, you can trust the previous links, basically. But definitely that's a good comment about being able to reuse these links. Thank you.
So notice it was a lot of what Archie had was based on code analysis, right? But oftentimes, when you have a bigger architecture, it's more than just one app. And even if you were to include all the projects that, let's say they're all Java, you still would have trouble with the way they interact. How do you classify or call out those decisions and protect those?
Let me just clarify to make sure that I get it right. With the way you interact, you mean those kind of design decisions which are structural, are about dependencies between components rather than those which are internal.
Yeah, the way they interact. I mean,
so there is one thing.
Let's say you got a database. So you didn't have a database on there, and you have the way that the application interacts with the database. You're changing something there, right?
So there have been a lot of work in the area of architecture, kind of discovery. The difference of Archie, we could read these kind of things that you point have been already explored by others. Rick has done some work on architecture discovery. So those kinds of things which are structural, they've been work done in that area. The difference with my work or our work is that we kind of went to the area which wasn't explored, and that was tactical architectural decisions in the code. But definitely there are other types of design decisions that Archie doesn't support right now. Those are structural analyses that are about architectural styles, how different components interact with each other, how we break the architecture into sub-modules, subsystems are not covered yet. And I think that requires other kind of methods that take into account the structure of the software.
Yeah, because if you talk, even within the structure, the code, if you make some changes, it may impact the upstream or downstream partner.
Yeah. So I missed your point. Okay.
No, I mean, even within the code, though, you could still impact the structure of the overall system, right?
Yeah, so that's true. So you might change, basically there is an execution path. You change something here, but it impacts several other use cases in the system. No, that's true, but what Arch at this moment does, it doesn't traces your change through the system. That could have been a perfect, if we bring such analysis into to Archie that would become even smarter. Right now, it detects. But what we like to do, we want to make, as I said somewhere in my slides, that we want to bring design knowledge, make it emphasize it for programmers. So those are sample kind of analysis that we wanted to incorporate into Archie that not only it identifies things, and also it can perform wise synthesis. That's not easy. Sometimes even humans have problem doing it. So that's something that we're interested in.
Thank you.
Thank you.